We figure that innovation happens when someone runs up against a problem or spots a need. So what problem or need was Vitesse designed to solve or address? Can you tell me just a little bit about how it got started?
Sure. So the major problem addressed by Vitesse is the integrative visualization of multimodal single cell data sets. And these often contain multiple types of measurements, including spatial and imaging data, quantitative genomic profiles, and gene expression data. And a key feature of HubMap is the diversity of experimental modalities used to measure organ and tissue samples. And we can see this in the long list of data types in the HubMap portal. Previously, visualization tools have focused on visualization of individual data modalities, for instance, with dedicated genome browsers or image viewers. And with Vitesse, we aim to support visualization of all the HubMap data types directly in the data portal.
Excellent. Thank you so much. Could you talk to me specifically about your role in its creation? What role do you fulfill there?
I began working on Vitesse as a summer intern and focused initially on a small component to manage the selection of cells. And later I applied to the bioinformatics graduate program. And now as a student, I've been working on the overall architecture of the tool along with other students and software developers in the Gellenborg lab.
Thank you. Can you talk to me a little bit about some of the challenges that the team encountered in its design or its creation or implementation?
A challenge in developing Vitesse has been making the tool scalable without compromising on the developer experience or on its serverless architecture. To overcome this, we use the WebGL technology in the web browser to render large data sets. And to load large images and gene expression matrices, we use the ZAR array storage format, which provides compression and concurrent access features without the need for any specialized server infrastructure.
I know you've already kind of hinted at this, but it'd be great to have a statement on this. So what is the most valuable contribution you see Vitesse making to its field? You already kind of said this with what problem or issue does it address, but could you just, but what are you most proud of? What do you think is its defining contribution?
We believe that Vitesse will be important for publishing interactive visualizations of single cell data as a component that's easy to embed into other websites with data sets stored in the cloud. And we've demonstrated this use case with the HubMap portal, and we hope that our documentation and tutorials will help other researchers to set up Vitesse and share their data sets on the web as well.
Great. Yeah, starting with the VH MOOC, which this will be part of, and a lot of people sign up for. So now could you take us through the highlights? Could you give us a tour, an insider's view of this tool?
So this page of the HubMap portal shows the details for a large intestine tissue sample assayed by co-detection by indexing, or the codex strategy, which allows up to 50 protein targets to be visualized within a single tissue section. And so the Vitesse component is embedded on this dataset detail page, which allows us to explore not only multiple image regions in this sample, but also cell segmentations, which have been derived by the HubMap automated data processing pipelines. So we can select a different region, and with the image channel controller tool on this left-hand side, we can select a different fluorescence channel for visualization. As we change the cell segmentations, we can see that in yellow, we have a number of cells that the pipeline has segmented for us. And so as we scroll down past Vitesse, we can also view provenance details for this data set, and we can also download the raw or processed files. So on this page, we see the main documentation for the Vitessce tool. So for researchers who would like to embed Vitessce in their own website or use it in the Python or R programming languages, they can come here to learn more. We have a page with documentation and some tutorials. And we also have some demos, including some which are derived from HubMap datasets. For instance, this page which showcases an attack-seq dataset. So here we can see the power of Vitessce for not only imaging data, but also these other modalities, such as chromatin accessibility. And on this scatter plot, each point is a cell, and we have the cells colored by clusters, just derived by an unsupervised clustering method. And then above this scatter plot and cluster information, we see a genomic profile for each cluster. So these colors correspond to the clusters, and we can zoom in for a more fine-grained view along the genome.
What are we seeing there with the different levels of things there?
So these bars
Yes.
represent chromatin accessibility for each region of the genome. So, and then these are associated with each cluster. So these are aggregate accessibility profiles for each cluster.
And does this allow you to change the view at all, or change the color scheme? And
so if we select our own set of cells, we can annotate this with our own name, and we can also change the color. And in the future, we plan to implement features to view even beyond this aggregate cluster level information, and move toward visualizing a genomic profile for every cell.
Wow, that sounds really great. Very exciting stuff. Mark, thank you so much. I think that's all. That's a lot we can use, and I really, really appreciate you taking the time out of your day. I'm sure you guys are busy, but I really appreciate you stopping by and chatting, and I know that our students will really benefit from this. So thank you very much.
Thank you for interviewing me.